Hey everyone, welcome to the new episode, the 5th episode so far of Make Live. I'm Tyler Weingartner, and today I'm joined by
Matt Stoltz.
So Matt Stoltz, you are our digital fabrication expert here at Make Magazine. You're our editor. You run our digital fabrication review. That only has a little bit to do with the project we're working on today, because otherwise the project we're building today is the PiKon Raspberry Pi powered telescope, and it's a project that you worked on.
I started redesigning some of the parts to make them a little bit easier to find pieces here in the U.S. To make them. Although we're still working on some of that.
Yeah. So this is a project. Do you remember the name of the guy who originally developed this project?
I don't.
Well, good thing. Yeah, we've got it here with us. My apologies. So this project was originally developed in the UK, and it is based entirely around 3D printed parts and plumbing parts. This is a piece of PVC plumbing pipe, and this forms the body of the telescope. And you can see, look down, you can see right now, so this forms the body of the telescope, and this is a type of PVC pipe that is very common in Europe and the UK, not so easy to find here.
5-inch internal diameter PVC, which here in the US, 4 inches is really popular. 8 inches is really popular, not really popular, but findable. But 5 inches is it's kind of difficult to get.
Right. So you're working on redesigning the parts so that people can more easily build this here. You can purchase this online if you go shopping in online European hardware store, things like that.
And they'll send you the entire kit. And if you find some specialty PVC suppliers, you can definitely get the PVC here in the U.S. that is 5-inch internal diameter. But we're working on trying to find some ways to make it a little bit easier to source parts here in the U.S.
Yeah, that's the other important thing to talk about with regards to this project, is that there are a number of ways to go about building it. Because this is a completely maker-based project, you can look up the PiKon website. You can download all the STL files that you can print at home, and then get your own Raspberry Pi, get the Pi camera, get the cable, and then you're off and building. Provided you can get access to and find the correct size PVC pipe. You can also buy this project as a kit. They will have printed all the parts for you. They have to send you the pipe. You can paint the inside black because it's normal interior white color PVC, and that's not good for astrophotography or stargazing or anything like that. Paint the inside black and you're good to go. Or you can also buy this as a completely built kit straight from them. They ship you the finished telescope, and you're ready to start looking at the stars.
And there's a couple tricky bits in the system that when you buy the pre-built kit, they already do for you. Like the camera module itself will turn on an LED every time it tries to take a picture. Well, you're trying to capture minute amounts of light. That's how a telescope works. So you got to black out that LED. And if you buy the kit from them, they already sell it with the LED painted black, so you don't have to worry about how opaque is my paint. Am I using the right thing to make this happen? Yeah. It just comes ready to go.
And we've actually already got. I was going to say, if you have any questions for us regarding this project, please put them in the comments below. And we already have one good comment. I don't know the answer to it, but it's good to look it up. Anyone know if McMaster Car carries this pipe? I don't know if they do.
From when I was looking, I did not see it.
Okay, good answer there.
But again, there are specialty PVC companies that you can definitely get it from. So the internet provides, right?
Yeah, and of course, Ian Blanchard wants to know if a rubber chicken is required tool for the project. No, at least we don't think so. It's always good to have on hand just in case. And before we go any further, one thing I definitely want to do is make sure to thank our sponsor for the Makes Live series, and that is DigiKey. If you're not familiar with them, DigiKey is a electronics supplier based here in the U.S. They sell all the electronics components that you need to build this project, the Raspberry Pi camera, and basically anything else you would need for this project or any electronics project. They ship fast. They're a wonderful partner to have in this series, and we're grateful to have them on board because they make this possible. So thank you, DigiKey.
They've been my go-to shop for years for ordering components. Yeah. Best selection, great shipping time, and I can say that because I've been a customer for longer than I've been with Make.
Yeah, that's true. They're tremendous to work with. And this upcoming weekend is Bay Area Maker Faire. They're going to be joining us out there for the event, and I'm really looking forward to actually meeting with them in person. So thanks, DigiKey. And but anyhow, let's get on with building this telescope. And Okay, I just wanted to see if we had any more comments. So, the components we have here, we mentioned here's the PVC body. We're going to set this aside for now, so we don't, we're actually going to need this pretty soon. So let's get this out here front and center. The other components to this.
Yeah, there's two main assemblies that go into this. There's a base that holds the mirror,
Yeah.
And that's the first thing here. We already have this partially assembled.
Yeah, let's get a closer look at this guy here.
If there's any point of this build that you really need to pay close attention to what you're doing, it's when mounting this mirror. You know, when we start talking about telescopes, we're talking about precision optics, and so the best you can center this mirror when mounting this mirror to the adjustable mount, the better off you are.
Yeah.
After that, there's spacers that are in here that there's screws and some springs in there, so you can actually change the height. Where's the camera? Okay, so you can actually change the height of the mirror, making sure that those at least start out evenly spaced. So if you have to dial things in, you're not dialing from wide gradients. Really helps.
Yeah, and then you have all these adjustment screws that are available on the back of this this cap here that then you can use to make those fine adjustments later on.
But if your mirror's not centered to begin with, there's problems.
Yeah. So anyhow, the first thing that we can do is actually just go ahead and fit this in here. If you're building this permanently, you would probably want to glue this. But right now, it actually works with a pretty nice friction fit. So that's going to stay pretty stable for us there. And then the next part of the assembly, and actually we have two different parts of this. So this is referred to as the spider. And this sits at the open end, and as you'll see, we'll build this in just a moment. It has sort of a rack and pinion thing that mounts the Pi camera, and then the Raspberry Pi itself is bolted to the outside. And so this basically forms your focusing apparatus. And if you take a look, so this is the one that that is the normal 3D printed design that they either sent to us or you can print your own. And this is the one that Matt designed, so you can see there's a pretty considerable size difference for the European PVC pipe and the US one. Okay.
All right. Here's the rack.
The rack you can actually assemble, you can actually insert later on.
Yeah.
Get it here a little bit closer. Ian Blanchard is asking, what level of expertise do you need to assemble this?
It's the instructions are actually really easy to follow along with. And so it's if you can build a piece of IKEA furniture, you're going to be able to put this thing together.
Yeah, so we just fit this in here, and there are just a couple of grub screws there. Actually need to go in here and grab an Allen key. Straight back around here, just so we can get these set screws tightened up. And of course this Allen wrench has some sort of nail polish or something on the long end, so I can't use it for gross getting this threaded in quickly. So just got to take our time with it.
Here, I'll help if I hold
I almost got it. All right. So that's a rack and, well, that's the pinion, part of the rack and pinion setup. And then we just attach this handle to the outside. The handle's also 3D printed. And then just have this little acorn nut to secure all that into place.
This piece just makes it easy to focus the mechanism. Again, the mirror length or the mirror size is already has a focal length about the same size as the tube. But to be able to truly focus in, being able to move this rack and pinion helps.
Yeah. And now we see how the rack and pinion sets up. We can just roll this into place, and then so there's a little bit of a toothed, rubber toothed gear thing, and then
GT2 belt.
Okay. And this is mostly, well, you probably know this from working with 3D printers and probably having built some yourself. These are all basically 3D printer parts, aren't they?
Absolutely. These are the same pulleys and the same belt that we use on most printers.
Yeah. Of course, they've been used for countless other things before there were 3D printer parts. So the next thing we'll attach is the Raspberry Pi camera, and you might notice if you've seen a couple of these things, there's a really critical difference here going on, and that is that, so normally there'd be a lens here, but because we're already going to be focusing this through the mirror assembly at the back of the telescope, we actually don't need the lens. And I'm no, well, I'm a videographer, but I wouldn't call myself a professional optical scientist. I don't know the word for that. I mean, there are certainly some lens assemblies where you can focus through two lenses, but here we're just focusing through one. So right now you're just seeing the bare sensor. You can just unscrew the lens and it just comes right out.
It's a little tricky. It is the lens is held in with a little bit of like Loctite kind of material.
Yeah.
So you got to be kind of careful, but you have to remove that lens. It's easy enough, but just be patient.
Yeah. Like with all things. And then we hold this. Actually, I probably want to get the ribbon cable installed first. That will probably make our lives easier. So
So as you can see here, one side of the ribbon cable has a blue strip on it. That's an insulator. You want to make sure that the actual bare connectors are facing down towards the board.
Yeah, we'll take a look at the other side of it. There's the connector side of the ribbon cable, and there's the insulated side. And for me, I always just look at what side of the connector the actual contacts are on, and that's how I know to align it. But I haven't done enough of these to really have fully internalized which side is which. And then to hold this in place, we just have these little nylon nuts and bolts. And these just go through these 4 mounting holes.
Nice and non-conductive, and you can't really torque them down too much, so you don't really have to worry about, damaging your board.
Although
they like to go missing because they are
if you drop them,
they are little.
They're tiny, and you'll never see them again. Which I think is exactly what I've done.
All right.
Maybe for this build we'll only have 3 mounting points. That's good enough.
We'll find that other at some point.
John Madden asked if PLA is fine for this assembly to print in.
PLA is fine for this assembly, and in many ways is great. The only thing that I'm going to warn you about on PLA is if you intend to mount this someplace where it might get some direct sun, like if you're going to have it permanently in a window or something like that, you could have the potential of having melt. But normally, normally you're going to be using a telescope at night, right? And so you're not going to really have to worry about temperatures too badly. But I would just not keep it in the window of your home set up to permanently stargaze out of, because it might melt.
You mentioned that you can't really torque these down enough, and that's why I'm just using the old fingernail screwdriver here. And maybe you can speak. Well, I'm sure you can speak to this better than I could. But I tend to find that, especially when you're working with fairly close tolerances for mechanical parts, PLA has a little bit higher reputation for dimensional accuracy than other materials. But you probably with more exotics than I do.
Yeah, so PLA has a lot less shrink, so it's really great for those cases where you don't want. You don't want to lose any of this mechanical or dimensional accuracy. the one side of it is it has less give. It's more brittle than ABS, and ABS is easier to kind of post machine and work with later on. So really see what your setup's like. If you don't have problems printing in ABS, then ABS is probably great. If you do have problems printing in it, then stick with the PLA or look at some other variants. We're also getting a lot of really nice high temp PLAs now that have a lot less melt problems. So that could be consideration.
I was going to say that maybe it's just my experience with it, but I also feel like the overall quality of PLA has been generally improving, and it's losing its reputation for being quite so brittle of a material.
Well, there's a lot of additives that are being added in to try to combat that. So we're seeing a lot of variants out there. There's the PLA PHA, there's the high temp PLAs, the stronger PLAs that people are doing. But yeah, you just know the material that you're using.
Right, and actually, Matt, could you look in the drawer behind me there and just grab a small screwdriver? There you go. Thank you. A couple questions about printing this in PETG.
So PETG is great. The only thing is some of these components you're going to want to make sure that they're a bit opaque, so you're not getting a light bleed. PETG typically is clear, so if you're actually printing in PETG some of your back pieces, you might get light bleed from other sources that's coming up and hitting your camera, and not necessarily just the light that's being reflected back by the mirror itself.
Yeah. Okay, so this is the spider assembly, relatively complete. Then actually there's one more thing we needed. Oh, found the other nylon screw there.
There we go.
It found itself wedged right there in the rack and pinion, which would have messed us up real good when we started trying to focus this thing. Now, of course, it is 3 in the afternoon here in San Francisco, which means we're not going to be able to do very good stargazing. But one of the features in our new office is that we're looking directly across to a set of floor-to-ceiling windows out to the Embarcadero, which is San Francisco's harbor front street. So without seeming too creepy, we're going to just point the telescope right out the window and maybe see some passersby, or take a look at get a good close look at the leaves that are on the trees outside, or we'll see what else we can see. But it will give you a pretty good sense of the level of magnification that this telescope is capable of. Do you know off the top of your head what the magnification factor is?
Again, I do not remember.
Okay.
These are questions that I did not bone up on before coming here. Been spending more time thinking about designs and expandability.
Yeah. Okay. So that's the last part there, and then let's get the. So this is the bracket that we're going to mount the Raspberry Pi onto. This will kind of hang off the outside of the telescope here. It mounts to this point right up here, and we'll just use this screw to thread that on in.
So this is one part that you will need to prep as you're preparing. There's a printout template for this, but the actual mounting hole is not built into the design. It's something that you actually need to drill out yourself.
Do you know why they didn't integrate the drill hole into the design?
Absolutely befuddles me.
Okay. Well, that's the interesting thing about community projects is you don't always work on them close together enough to be like, why did they design it this way? But that's all right. The aforementioned Raspberry Pi, let's just go ahead and mount that on here now. Pull this camera up a little bit. What I probably should have done first, so I'm going to take this back out of here so I can mount the other end of the ribbon cable into the Raspberry Pi.
A little bit easier.
Yeah. I realized that as soon as I was finished. How does this case open? All right, got the camera there. The contacts are on this side.
You should put that through the top of the case.
I'm glad you're here to help me. I'd just be making all the mistakes.
Teamwork gets things done.
And Patrick Carroll has found a listing for 5-inch diameter, 5-foot long, Schedule 40 PVC pipe for $33-44.
There you go. Might be able to organize a group buy there on the.
I mean, the length you need for this design is only 2 feet of the pipe, so that's good for two telescopes. Although that last foot long remnant wouldn't be good for anybody, I wouldn't believe. And the John Madden mentions there's no. So the mirror is a item that you'll need to purchase on. I believe it's available on Amazon. And as far as the lens, all you'll need to do is buy the Raspberry Pi camera. That's the only thing you'll need. And then the mirror you can purchase on Amazon. If you take a look at the PiKon website, if you look on PiKon, PiKon, Google that, you'll find their website, and they also have the rest of the bill of materials for all the mechanical parts.
So this is considered a single optic telescope, in that the mirror is the only actual optical component of the telescope. There is no secondary lens.
In fact, as we mentioned earlier, the Raspberry Pi camera comes with the lens that you will be discarding. All right, so the last part of this is to assemble this all into the telescope. Now, if I remember correctly, this works best. I think actually you have the handle of the telescope pointing off to the right with regards to the mounting point of the telescope being on the bottom. But we'll get this all fitted in, and then we'll take a look, and we'll make an adjustment if the picture is upside down.
Right. That's actually one of the suggestions, is not to really affix things until you've tested everything. Get your picture, get your focus, and then rotate your components to get your image right side up. Because your mounting system may be different. You may be mounting straight down. You may be mounting to the side. We're just using a normal camera tripod for this, but if you were actually using a tripod that was actually designed for telescopes, then your mounting point may be different. So don't worry about really locking things down until you've really set everything up and given it a try.
Yeah, so let's grab that tripod back there.
All right.
This one is a little lightweight for our needs. A lot of our equipment is already making its way down to the San Mateo Event Center for Maker Faire, but it should be good for our needs. The benefit of this design is that it's all 3D printed. It's made of basically drain pipe. It's very lightweight. All right, so we have that mounted on the.
Not quite.
Maybe I have this plate in the wrong orientation. I'm not getting good bite on it. Let's try it that way. What is going on to this? I think I see. The little thumb screw keeps folding down and not letting it sit flat into the mounting point. And this
is why blue painter stick is invented.
Yes.
Where can I find some?
To show the problem that we're dealing with here
Here we go.
is that this little thing we can use to tighten the tripod plate keeps wanting to fold down and get in our way.
Problem solved.
I wasn't sure if we'd have a troubleshooting segment of this build, but now we have.
There we go.
Okay, that's a telescope. Now we just need to be able to see what the telescope is seeing. We need, of course, our HDMI cable. And we'll need to punch in a couple of commands. For that, we will use this fine keyboard. And finally, we need to give the Raspberry Pi some power. Okay. Now we're just letting the Raspberry Pi boot up here. John Madden is asking again what OS is needed. The OS that we're running is the standard Raspberry Pi Raspbian OS. It's the one that comes with most distribution, or it's the one that if you go to raspberrypi.org and download the OS, it is one of the most prominent ones. It's the one that they developed specifically for the Raspberry Pi.
It has really great community support, so it's really useful. That will increase the expandability of this project a lot, that they stuck the Raspbian.
Yeah. Now, this project is so simple, there's not even really software to install for it. Really all we're doing here is we're just going to be logging in as the standard Pi account. And it could, depending on if you're downloading this, really the only thing you need to do is go into the Raspbi config command, and really the only thing you need to do to get this thing ready to run is to enable the Raspberry Pi camera. Of course, to make your keyboard make sense, you might need to go into the internationalization options, set your correct keyboard layout. We've already done that here. We'll go ahead and say yes, we want to reboot. So it needs to do a couple things to get the Raspberry Pi camera ready, and then after that, we're ready to take a look and see what's going on outside.
So one of the really great things about this project that I kind of alluded to is because it is open source, because it is based on the Raspberry Pi, and that there is such a community around that. This is a really expandable project. It's something that I'm starting to play around with and look into, but I would really love to see a community spring up around it. The Raspberry Pi is really being underutilized here, and there's a lot more that we could do. Adding this onto some kind of Dobsonian manipulator to aim the telescope so that you could select an item and have it jump right to it. The Raspberry Pi shouldn't have any problem being able to drive something like that. So there's a lot that we can kind of add on to this system as is.
And for people who aren't familiar, what is including myself, what is a Dobsonian?
Dobsonian telescope. So Dobsonian telescopes have a series of pivots on them that will allow it to be moved around and looked at certain areas. It's an easy way to mount a telescope.
Gotcha.
At least I think I have that correct. 99% positive on that.
I was so excited to get this thing running and looking out the window that I started typing in the command that will show us the output of the camera before I'd even logged in yet. So yeah, really to just run this, we're running the Raspberry Pi camera capture command, which is raspi still. Probably don't need to capture the image into a file, but and then we're also going to do this -t and then set the number of seconds we want it to preview for. Or actually, no, the number of, pardon me, milliseconds. That translates later into seconds, and I think this is going to show for a good solid 2 minutes. And then F/ command, and we see a very blurry picture. So let's start focusing to see what kind of image we can resolve. Might also be that we're just looking at.
Yeah, I think we might have the curtains.
You look like you're right. Okay, so we're probably pointed.
Yeah, now you're starting to see some grass.
Also looks like we're focusing a little bit on some of the leaves. We have leaves. These are the leaves on the trees outside our window. So apologies for the wobbly camera. Try and stabilize this as much as possible. But for sake of reference, I would say that these trees are probably about 200 feet away outside our window. And so that gives you a good idea of the amount of level of magnification that we're capable of getting with this. I'm going to try and lower the column on this a little bit. It'll probably stabilize things a little bit and keep us from being pointed directly at the out the window, or at the window shade.
The primary suggestion when tuning this in is to try it on the moon. So trying to tune this in during the day, we're kind of trying to focus on things that are a bit too close. I think you can definitely see the potential here.
Nope.
Oh.
We just need to run that command one more time so we can get a little bit more preview time. Trying to focus on that wall just past it. I think that's what that black line you see towards the bottom of the image there represents. Well, there's a pole there. And I would say that marker there is probably 6 to 8 inches tall. And again, that's probably a good 200 feet away from us here.
That's on the other side of the road, isn't it?
No, it's on this side of the road. Actually, no, I think it's in the middle of the road. I can't quite tell from here.
I can't figure out which pole it is. Oh, there it is. Okay. Yeah. Yeah, so that's in the middle of the road. So that's
maybe another 30, 40 feet away.
Yeah.
I'm going to find out.
Mike is going to find out for us how far away this is. So, I mean, that's just a really quick look. I mean, obviously this isn't the most optimal setup to demonstrate the capabilities of this, but it's really easy to see the potential of what this thing is capable of. Aside from the printing time, this thing assembles super fast. I mean, if you look on the project page on magazine.com, I think it lists 14 to 16 hours. I think that's all entirely print time.
right.
I mean, I printed this large spider last night with the larger one for the 6-inch diameter pipe. I want to say, I mean, I was printing this at 0.2. You might need this to be a little bit thinner layer height, but actually it's plenty strong at this layer height. And this was like 4 hours, and this is one of the more complex parts.
Right.
There's not a lot of print here. You also can print out this where did that little dovetail go? The kit also comes with a dovetail mounting plate for standard and astronomical tripod. Those are pretty commonplace if you have that sort of equipment. We don't, so we did this little bracket mounting system and then used some 1/4-inch aluminum to just tap that so that then I could use it for a standard photographic or videographer's tripod. That would make it easier for us to mount in here, but you can also print up the normal dovetail for for the astronomer's tripod.
Right.
Keep getting those fumbled up in my brain. But anyhow, so this is an awesome project. We love it. We hope you'll go on and build it. And again, we're also super grateful to DigiKey for making this series possible and making the parts available for us. If you check the link that was posted in here, you can buy. There's a shopping cart already ready for you to purchase all the electronic components you need to purchase this project, and then you can go and purchase all the mechanical stuff, the mirror, and then you're ready to build this project. You're ready to see amazing stuff in our solar system.
Right. First one of you guys that turns this into an IoT telescope and sends us a link, we will get your telescope up and out there so people can stare at the stars through your telescope with you.
Yeah, can't wait to see that. And also things that we cannot wait to see. If you're here in the Bay Area, I really hope you're coming out this weekend to Bay Area Maker Faire in San Mateo. If you're not here in the Bay Area, we are going to be doing a live stream of pretty dang near the entire fair, or at least everything that we can fit into 16, 17 hours of broadcast time over the course of the weekend. And you can catch that not here on Facebook, but over on our Twitch page, over on Twitch Creative, and that is twitch.tv/make. We're going to be streaming Friday, Saturday, and Sunday, and you can go ahead and take a look on that site to get a rough idea of our schedule. Some things will be changing over the course of the weekend, but there's a lot of really cool stuff that we're super excited to see, and we hope you will join us. But in the meantime, thank you, Matt, for joining us.
Thank you for having me.
And thank you for watching. Thank you for your awesome comments and questions, and we will see you in the next Make Life Build. And once again, thanks to DigiKey for making this series possible, and thanks for being here. Have a great day. Bye-bye.
Thanks.